Hi friends, this is an IBM guided project, a gesture-based tool for sterile browsing of radiology images, a capability of a software application to recognize a hand gesture for a contactless validation of radiology images. Our main objective here is there are lots of professions where sterile browsing is necessary. One of them is medical profession. In order to maintain hygiene and to avoid contamination of diseases, to tackle with this, we have created a software called as a gesture-based tool for sterile browsing of radiology images. Now let's move on to the technical architecture. So here in this technical architecture, the user enters the input in the user interface, which is nothing but the hand gesture. This input is processed in the main model. On the other hand, a huge dataset of hand gesture is being pre-processed in the data processing unit. The model is being trained with an artificial intelligent algorithm, which is then evaluated and predicted, and the necessary operation take place according to the prediction, like resizing and blurring the image, etc. And it provides an ability for the user to do the desired task using a simple hand gesture workflow. We have downloaded the dataset and used convolutional neural network for analyzing the visual images, which is nothing but a part of DL algorithm, which is nothing but deep learning algorithm. We have imported Flask, which is a popular Python web framework, which is a third-party Python library. We have trained and tested the model using deep learning algorithm.
Next, let's move on to the coding part. The Python platform we used is Jupyter Notebook. So this is our Git repo where we have uploaded the source code for our project. So the first step in our development phase is dataset collection. We have downloaded the dataset from the provided link in IBM. So the folder consists of two files containing of images of hand gestures from 0 to 5, which is used for testing and training the model. So next is image pre-processing. So image pre-processing is done to format the images for color correction, which is for training the model for a better accuracy. So the image data generator library is imported and then the data is loaded for data augmentation. Then the next step is building the model. So for building our model, we use CNN. We import the necessary packages such as NumPy, Tensorflow, Keras, etc. Then we initialize the model. Next, convolutional neural layers are added like max pooling, flatten, dense layers, etc. So this is the summary of our model. Then we train our model. So using epochs. So an epoch is the number of iterations for training the data in one particular circle. So we trained our model for 25 epochs. Then we save the model. The model is saved as gesture.h5 and a JSON file which is called as model-bw. So after training the model, we test the model. So the images are loaded and then we import some more packages like matplotlib, which is used for plotting. Then the results are predicted. Here the model is built and trained successfully. Next we move on to application building. First we created 3 HTML pages for home page, the main page. So this is the code for the home page. Next is the introduction page. So the introduction page, it just gives a gist of what our page is about. And then finally the launch page where we predict the results. Then the final step for creating the application is the Flask program, app.py. So we use the Flask framework to connect our model and the HTML pages to form a web application. So in this program, we have imported libraries like CV2, which is an OpenCV library, then again matplotlib, Tensorflow, NumPy, etc. Then here the HTML programs for home page, the introduction page, and then the launch page which is used are loaded. The predictions for hand gestures for 0 is for displaying the radiology image in rectangle. 1 is for resizing the image in 200 dimensions. 2 is for rotating the image. 3 is for viewing blurred images. 4 is for resizing the images in 400 dimensions. And 5 is for viewing the image in grayscale. So we'll run the program. So here in the console you will find a link. So give Ctrl+click to open the web page. So let's get into the demo of our project.